In the brutal and chaotic battles that defined armored warfare in World War II, advantage often came down to fractions of a second and the smallest details of engineering. Tank crews lived inside steel shells where vision was limited, reaction time determined survival, and a single mistake could end everything in an instant. The roar of engines, the thick smell of oil, the tension of waiting behind narrow slits of glass. These were the conditions that shaped every engagement. Yet for thousands of Allied tankers, the most terrifying part of stepping into combat was something far more elusive than a gunshot or an explosion. It was the unsettling realization that their enemy could see them long before they could see the enemy. German tanks did not just strike hard, they struck first, often from beyond the range at which Allied crews could reliably identify a target. This invisible advantage cost countless lives and became one of the most decisive but least understood factors of the war. The reality of this imbalance became clear early in the conflict. Whether fighting in the deserts of North Africa, the hedgerows of Normandy, or the wide plains of Eastern Europe, Allied crews repeatedly encountered the same devastating pattern. German tanks fired the first shot with uncanny precision. Reports flowed in describing Allied vehicles erupting in flames without any warning, their crews unaware of where the attack had come from. Soldiers spoke of phantom enemies, hidden gunners, and shots landing at distances they believed impossible. For many tankers, it felt less like a battle and more like being hunted by something they could not see. German armor, especially the feared Panther and Tiger tanks, quickly became known not only for their thick armor and powerful guns, but also for an almost supernatural ability to locate and strike targets. The secret to this precision did not lie solely in firepower. While the German cannons were formidable, the true advantage was hidden in the eyes of the tank. Advanced optics developed through decades of meticulous craftsmanship. German engineers had created an optical system so refined that it reshaped how tank crews engaged in battle. Their sights were clear, bright, and remarkably accurate, even at extreme distances. The binocular design on earlier models provided depth perception that Allied tankers could only envy. As the war progressed, newer models incorporated variable magnification, allowing gunners to switch seamlessly between wide scanning views and highly precise targeting views. This technology gave German crews an unparalleled ability to detect movement, identify shapes, and track targets across vast stretches of terrain. The reason these sights were so effective stemmed from Germany's long tradition of optical excellence. Companies like Zeiss and Leitz had built reputations as global leaders in precision glass, lens coatings, and mechanical design. Their laboratories developed specialized chemical treatments that dramatically improved light transmission and reduced glare, using rare minerals and complex processes that few foreign engineers could replicate. The clarity of German lenses was extraordinary. Crews could distinguish details at long range that would appear blurred or invisible through Allied optics. This meant a German gunner could spot a tank, determine its orientation, calculate the distance, and fire in the time it took an Allied crew to simply identify a vague threat on the horizon. The brilliance of German sight design extended beyond glass quality. Their reticles, the aiming patterns etched inside the lenses, were masterpieces of practical engineering. Instead of simple crosshairs, German reticles used triangular shapes arranged in precise angular measurements. These triangles formed a built-in rangefinder, allowing gunners to determine distance simply by comparing the known size of an enemy vehicle to the spacing of the markings. Once the gunner identified the apparent size of the target, a quick mental calculation provided the approximate range. This system was fast, intuitive, and highly accurate when paired with the high-velocity guns mounted on the Panther and Tiger. As a result, German crews often achieved devastating first-shot accuracy at ranges exceeding 1.5 kilometers. Allied crews, by comparison, were effectively blind beyond 800 meters. Allied reports increasingly described engagements where German tanks appeared to fire with the confidence and rhythm of artillery batteries rather than individual crews. Allied units advancing across open ground often suffered heavy losses before spotting a single enemy vehicle. The psychological impact was severe. Tank crews spoke openly of their fear of German optics, treating them as a hidden weapon, as dangerous as any cannon. This fear was not unfounded. In many cases, German gunners did not need to reposition or scan frantically. They simply observed patiently through their crystal-clear sights until a target presented itself, then fired with deadly precision. The Allied problem was compounded by significant shortcomings in their own optical equipment. American sights, while sturdy and relatively easy to manufacture, lacked the clarity and sophistication of their German counterparts. Many had fixed magnification and narrow fields of view, forcing crews to physically traverse their turrets to scan the battlefield. This slowed reaction times and created blind spots. British and Soviet sights had similar limitations. Soviet T-34s, renowned for their rugged design and mobility, were notorious for their poor optics early in the war. Crews often described their sights as cloudy or unreliable, making accurate fire at long distances extremely difficult. As the war continued and Allied casualties mounted, commanders and engineers came to a disturbing conclusion. They did not just need better tanks, they needed to understand the secret behind German vision. Intelligence agencies made capturing enemy tanks and their sights a top priority. Specialized teams trailed frontline units, rushing into newly secured areas to examine wrecks before they could be destroyed or booby-trapped. They were looking for intact gun sights, periscopes, and optical components that could explain the extraordinary accuracy of German gunners. These missions were dangerous and often conducted under fire, but the potential payoff was enormous. Success came in the aftermath of major battles when German forces retreated in chaos. Abandoned Panthers and Tigers became treasure troves for Allied intelligence. Each recovered vehicle represented an opportunity to study and measure the enemy's advantage. When an intact Panther was discovered in Normandy and shipped to the United States, engineers finally gained the chance to dismantle and analyze the optics firsthand. What they found astonished them. The sight was beautifully constructed, with finely machined components, precision ground lenses, and elegant mechanical systems for adjusting magnification. The materials used in the sight were unfamiliar to many American engineers, particularly the rare earth elements embedded in the glass. Chemical coatings on the lenses absorbed reflections and enhanced brightness, giving the gunner a vivid and detailed view even in low-light conditions. The analysis revealed not only technical sophistication, but also a hidden vulnerability. German sights, while exceptional, were labor-intensive to produce and nearly impossible to repair in the field. Each unit required skilled craftsmen and complex machinery. If damaged in combat, a sight often had to be shipped back to a specialized factory deep inside Germany. This process added strain to already stressed supply lines. In contrast, Allied sights were simple, rugged, and easy to replace. This difference in design philosophy reflected the broader industrial approaches of the two sides. German engineering emphasized perfection and precision, while Allied engineering prioritized speed and practicality. Still, capturing these sights provided the Allies with invaluable insight. Engineers documented every mechanism and measured every lens. They studied how light moved through the system, how the reticle markings worked, and how the variable zoom function was integrated. These discoveries shaped the next generation of Allied tank design. Post-war tanks in the United States, Britain, and the Soviet Union all incorporated principles borrowed directly from German optics. Wider fields of view, improved lens coatings, and range-finding reticles became standard features, ensuring future crews would never again enter battle with such a crippling visual disadvantage. As intelligence efforts expanded, Allied forces continued gathering every German tank site they could find. Each new discovery confirmed the same reality. The optical advantage Germany possessed was not a coincidence or a trick of design, but the product of a national obsession with optical science that had matured long before the war began. Engineers noted that German factories were using advanced alloys and chemical processes that had no counterparts in Allied industry. Even the internal construction of the sites, with their intricate gears and carefully aligned prisms, reflected a level of precision manufacturing that pushed the boundaries of wartime production. For Allied analysts, the more they studied these components, the clearer it became that the German advantage was both technological and cultural, rooted in decades of research, experimentation, and meticulous craftsmanship. Meanwhile, Allied tank crews were still feeling the consequences of this disparity on the battlefield. Reports from the Western Front described situations in which German tanks seemed to dominate from positions that were barely visible to the naked eye. In one account, a Sherman crew advancing through a foggy French valley spotted a Tiger only after its first shot had already hit them. The German crew, using superior optics, had identified and ranged their target through the haze with relative ease. Similar reports emerged from the Eastern Front, where Soviet tankers described being struck from distances far beyond their own optical limits. The pattern was consistent. When a Panther or Tiger opened fire, it did so with confidence born from clear sight and precise calculation. This growing awareness led to a sense of urgency within Allied command structures. Understanding the enemy's advantage was no longer simply a matter of curiosity. It was a matter of survival and future preparedness. Engineers and researchers began working together across national boundaries to gather and share intelligence. British and American optical experts compared notes, exchanged samples, and analyzed German glass under microscopes, studying the distinctive patterns and mineral compositions. Soviet engineers, with access to German factories captured on the Eastern Front, provided their own insights into manufacturing processes and production lines. These combined efforts gradually revealed the full scope of German optical innovation and brought to light the strategic consequences of ignoring such technology. One of the most critical realizations was how deeply optics influenced the concept of first-shot engagement. In armored warfare, the side that fires first often gains a decisive advantage, especially when dealing with high-velocity guns capable of penetrating thick armor. German tanks excelled in this area because their optics allowed crews to acquire targets quickly, estimate range accurately, and fire with remarkable precision. This capability aligned perfectly with Germany's broader doctrine of concentrated firepower and rapid, decisive engagement. Allied forces, on the other hand, were forced to compensate through brute force, maneuver tactics, or overwhelming numbers. This imbalance shaped many battles, shifting the burden onto crews who were already fighting at a disadvantage. Yet, despite the severity of this challenge, the Allies eventually managed to adapt. The more they learned from captured German sites, the more they refined their own equipment. American engineers began experimenting with variable magnification systems and improved lens coatings, incorporating new materials into glass manufacturing. British designers focused on creating more intuitive reticles and enhancing field of view, recognizing the value of situational awareness. Soviet engineers, benefiting from both captured equipment and access to German scientists after the war, pushed their designs toward increased clarity and durability. Slowly but steadily, the optical gap began to close. The lessons learned did not end with World War II. In the years that followed, the influence of German optics became woven into the design philosophy of tanks around the world. The American Patton series incorporated advanced range-finding sights inspired by German principles. British tank designers applied the same lessons to the Centurion, creating one of the most successful post-war tanks ever built. The Soviet T-54 and its descendants dramatically improved their optical systems, abandoning earlier, crude designs in favor of precision-inspired models that reflected what had been learned on the battlefield. The echoes of German innovation could be seen everywhere, but more importantly, the lessons ensured that no modern army would enter a major conflict without understanding the critical value of vision. As armored warfare evolved, the role of optics continued to expand. The introduction of laser rangefinders, thermal imaging, and digital fire control systems fundamentally transformed the battlefield. But each of these advancements built upon the foundation established by earlier optical innovations. The principles of clarity, accuracy, and rapid target acquisition remained central to tank design. Engineers and commanders recognized that even the most powerful gun was useless without the ability to aim it precisely. The importance of seeing clearly, of detecting threats before being detected, remained a timeless truth of armored combat, unchanged even as technology marched forward. Looking back, the story of German tank sights reveals a deeper narrative about war and technology. It shows how a seemingly small component can influence the course of battles, shape the strategies of nations, and alter the development of military hardware for decades. While the Panther and Tiger tanks are often remembered for their imposing guns and thick armor, their true secret weapon was something far more subtle: the ability to see the battlefield with extraordinary clarity. This advantage magnified their firepower, increased their survivability, and allowed skilled crews to dominate engagements with disciplined, calculated precision. For Allied forces, confronting this advantage required not only bravery on the battlefield, but also determination behind the scenes. Engineers, intelligence officers, and analysts worked tirelessly to uncover the source of the enemy's strength. Their efforts involved risk, ingenuity, and a willingness to learn from the very machines that threatened their own soldiers. The capture and study of German optics represented a turning point not just in the war, but in the evolution of armored warfare. It demonstrated that understanding an enemy's tools is as critical as defeating their armies, and that technological insight can be as powerful as numerical strength. In the end, the Allied pursuit of German optical secrets ensured that future generations of tank crews would never again face such a devastating disadvantage. The knowledge gained reshaped military doctrine and equipment, influenced international design standards, and laid the groundwork for technologies that continue to define modern combat vehicles. It also highlighted a broader truth. Victory in war is often determined long before the first shots are fired, in the laboratories, factories, and minds of those who imagine new tools of battle. A lens, a reticle, a coating, each played a role in shaping the outcome of battles and guiding the evolution of military technology. The Allied effort to understand and adapt to these innovations was a testament to resilience and ingenuity. It reflected the determination to turn adversity into advantage and to ensure that no future adversary would ever hold such a decisive edge again. In the relentless struggle to see the battlefield clearly, the pursuit of precision became a defining element of victory. As history shows, the ability to observe, identify, and engage with clarity is one of the most fundamental requirements of any fighting force. In the complex and brutal world of armored warfare, vision is more than a convenience. It is the foundation upon which tactics, survivability, and effectiveness are built. The Allies' success in capturing, studying, and ultimately mastering the secrets of German optics marked a pivotal moment in military history. It ensured that the future of tank combat would be defined not only by armor and firepower, but by the ability to see and to act with unmatched clarity.